Hey everyone, welcome to today's Explainer. I am absolutely thrilled to guide you through this one, because today we're unpacking a really brilliant chapter called We the Travelers. Now you might be wondering, what on earth does human travel have to do with math? Well, as it turns out, pretty much everything. We're going to trace the fascinating history of human travel, from our very first steps all the way to our leaps into the stars. And we're going to use that journey to unlock the secrets of massive 5-digit numbers. Trust me, by the end of this, you're going to see large numbers in a completely new light.
Okay, let's dive right into our roadmap for today. First up, we'll look at the evolution of travel, followed by the math of reaching 10,000. Next, we'll cover reading 5-digit numbers, mastering the art of estimation, applying all this to distances in the real world, and finally, we'll wrap up with some really fun math puzzles and teasers. Let's get to it.
Section 1. The evolution of travel. To kick things off, I want you to think back for a second. When was the last time you took a really long trip? Where did you go, and honestly, how did you get there? Do you have any idea how much distance you actually covered?
You know, human beings have always been driven to explore, but the ways we actually do it have drastically changed. On one side of history, we've got ancient methods of travel, moving purely on foot or using animal-drawn carts. Actually, fun fact, boats were likely our very first invention for transport, even before those bullock carts. But contrast that with today's modern highways, just packed with cars and stretching endlessly into the distance. 100 years ago, far fewer vehicles. Today, the distances we cover are honestly mind-boggling. And here's the core concept we're exploring today. As our world expanded and the distances we traveled grew, our numbers literally had to get bigger too.
Moving on to Section 2. Reaching 10,000. So, this massive expansion in how we travel creates an incredibly fun mathematical problem for us. How exactly do we write numbers to show several thousand objects, or thousands of kilometers? I mean, we know how to start with 1,000, but what happens as we just keep adding to it?
Think about it. We count up 1,000, 2,000, on and on all the way to 9,000. But what happens when we add a single thousand to 9,000? Bam! We reach a massive milestone. We hit our very first 5-digit number, 10,000. Written out, it's a 1 followed by 4 zeros.
Now, what's really interesting here is how our mathematical system elegantly adapts to this milestone. We've always used a place value system, right? Ones, tens, hundreds, and thousands. But to accommodate 10,000, we have to introduce a brand new column, TTH. It stands for 10,000. It's so cool because just like 10 ones equal 110 and 10 hundreds equal 1,000, 10,000s perfectly equal 110,000. It's just a beautiful logical progression of the base 10 system we use every single day.
Section 3. Reading 5-digit numbers. Okay, so we've got this powerful new column, but how do we actually read and construct these massive new 5-digit numbers out in the wild? Well, we still rely on the exact same 10 digits we've always used, 0 through 9. We just place them in different spots.
Let's break one down together so you can really visualize how the parts build the whole. Take a look at the number 45,867. We can deconstruct this right across our new place value chart. We have 4 10,000s, we have 5,000s, we have 800s, 6 10s, and 7 ones. When you pull it apart like a giant puzzle, a seemingly intimidating 5-digit number suddenly becomes incredibly approachable, doesn't it?
So the crucial point here is how we communicate this clearly. Notice the comma? We use that little comma as a visual cue to help us read large numbers easily. It basically groups the thousands together for us. So matching the digits to their written English name, we read the numbers before the comma together as 45,000 and then the rest as 867. Think of the comma as your anchor, separating the thousands from the hundreds.
Section 4. The art of estimation. Look, mastering exact numbers is great, absolutely crucial, but in the real world, especially when you're traveling, exact numbers aren't always necessary or even helpful. Sometimes we just need to quickly estimate. Let's look at this through a strategic little puzzle straight from the chapter.
Picture a hungry little rabbit currently sitting at position 2,346 on a number line. Its food sources have been placed exactly at the neighboring 10s. So the strategic challenge for you is, which 10 should the rabbit jump to in order to reach its goal with the absolute minimum number of steps? Does it retreat to 2,340 or push forward to 2,350? If he said 2,350, you hit the nail on the head. It's the nearest 10 because it only requires 4 jumps forward, whereas going back to 2,340 would take 6 jumps backward.
And that right there is the whole essence of estimation and rounding. We can apply this exact same logical mapping to even larger numbers, finding their nearest hundreds or nearest thousands. For instance, take the number 3,176. The nearest hundred, that'd be 3,200. The nearest thousand is 3,000. It's really all about finding the closest anchor point on the number line to simplify our math.
Section 5, distances in the real world. Let's take what we've learned and build it back into the physical world of travel. We've got the big numbers down, we've got the estimation skills. Now let's look at what these numbers actually represent when we're out there moving across the globe.
And this brilliantly illustrates the sheer, mind-blowing scale of human transport. If you're traveling for an hour on foot, you might cover a tiny one-digit number, about 3 to 5 kilometers. Hop on a train, and in that exact same hour, you jump to a 3-digit number, covering between 40 to 160 kilometers. But if you strap into a spacecraft, no way, you're not going to believe this. In just 1 hour, you are covering a staggering minimum of 28,000 kilometers. From a one-digit walk to a 5-digit orbit in the exact same time frame. This is exactly why we needed to invent the 10,000s column in the first place.
Section 6, Math Puzzles and Teasers. All right, you've mastered 5-digit numbers and real-world scaling. To wrap up our explainer today, it's time to put on your strategic thinking caps. We're going to look at some brain-teasing puzzles from the chapter that test how well we really understand number logic.
First up is Mira's incredible subtraction trick. Here are the rules. Take two different digits, let's say 3 and 7. Make two two-digit numbers using them, 73 and 37. Now subtract the smaller from the bigger. 73 minus 37 equals 36. Okay, now repeat the process with the digits of your answer. 63 minus 36 equals 27. 72 minus 27 equals 45. And finally, 54 minus 45 equals 9. Mira made this startling discovery. No matter which two starting numbers you choose, if you keep repeating this flip and subtract process, you will always end up with the one-digit number 9. It's a stunning mathematical pattern hidden right in plain sight.
And we're going to end on a truly mysterious story. Once upon a time, a king had 20 prized horses kept in a square stable, while one night a thief stole a single horse. Fearing punishment, the clever caretaker rearranged the remaining 19 horses in the stable's outer stalls. The next day, he led the king around the square, asking him to count the horses along each side. The king, counting along the edges, fully believed all 20 were still there. So our explainer ends with this fascinating unsolved puzzle. How exactly did the caretaker arrange them to trick the king? And critically, how many more horses can the thief steal before the king finally realizes the math doesn't add up? I'm going to leave that one for you to figure out. Thank you so much for joining me on this mathematical journey today. Keep exploring.